Hello everyone, my name is Yudong, and I'm from the University of Nevada, Reno. The topic I'm going to present today is the durable and cost-effective 3D Microforce sensor for musical tuning enhanced micropalpation of the biological entities. And here is the outline. First, I will introduce the background and objective. The second section, I'm going to be talking about the micropalpation system with the durable 3D Microforce sensor. For the third part, I will show you some preliminary results, and then I will conclusion my job. And the micropalpation is belong to the area biomechanical characterization. The reason why we need to learn the biomechanical characterization is because it can help us to understanding the biomechanical properties of the bioentities and the mechanical properties of the mechanical biomarkers. Also, it can help us build the physical model of the. It can help us build the physical model for the biomedical and the psychological studies. The current technology that we are using is the high-cost AFM processing and AFM measurement and processing them offline. Instead of use the high-cost fragile offline system, we want to create online durable low-cost system. So our system will include the developed cost-effect and highly sensitive 3D Microforce sensor and Microforce and a transfer function will convert the Microforce to the musical tuning for hearing and identification at real time. And here is the sensor firm that we are using to build our 3D Microforce sensor, and it has the highly sensitive, it's very thin, flexible, light, and low cost. Also, it has a widely temperature range, low thermal drift, and low hysteresis. Also, it's a robust and reliable sensor firm. This is the example that how we test the thermal drift. How we test the thermal drift of the sensor, and from the experiment we can find that the thermal drift of the sensor is very low. It's less than 2%. And this is the sensing calibration that we are using the bimodal sensor to calibration our sensor. This is the experiment setup. We fix our sensor in a stage, and we use the micro manipulator to push the bimodal sensor, push our sensor under the microscope, so we can see very clean here, and we can get the force data, voltage information, and the deformation by doing the experiment. This is the experiment result. By the experiment result, we can see our sensor can follow the reference sensor very well, and also by the experiment, we get the spring constant of our sensor is 27.16 Newton per meter. After the first calibration, we do the second calibration, use the high. After the first experiment, we do the second calibration, use the high accuracy sensor to verify our resolution, and we found that the resolution of our sensor is around 10 nanonewtons. After we verify the principle of our Microforce sensor firm, then we start to build the structure of the 3D Microforce sensor. Here is the result for the Einstein simulation, and the structure of our sensor is we have a standard, and we have a sensor tip. We have 4 sensing firm, and each firm has the bottom and the top layer with the sensitive materials. And by the simulation result, we can find out the deformation. If deflection is symmetrically when we apply force on X, Y direction or Z direction. And this principle is very important when we design a 3D self-decoupling microforce sensor. This is the mechanism of the self-decoupling microforce sensor, and this is our sensor layer. And you can see there has bottom and the top sensor materials on the beam. So, for example, when you apply force on the X or Y direction, the one side of the resistor will increasing, the other side the resistor will decreasing. The whole schematic is symmetrically, and then this table shows the resistor change for every situation, and it will be used later into the Yudong bridge to cancel the voltage output. And this is the second mechanism, but we find a problem is like the voltage changing rate for the bottom layer and the top layer is different. So that's the reason we choose the half bridge of the Yudong bridge to solve this problem. The RC is the constant resistor, and this is the output voltage, and this is the output voltage of each X. So you can directly get the output voltage by the equation. And here is the experiment result that we are tested the 3D self-decoupling. And we can find out the green line is the reference force, and we can find that the red line can follow the reference force very well, also for the other situation. But there was one problem is since the structure of the sensor, the Z direction has harder deformation than the XY plane. So we give the 50 times gain on the Z direction to make it follow the reference. And after we get the Microforce, we use a method to convert Microforce to the 88 key piano frequency. So since the piano frequency covers from 27.5 Hz to up to 4,186 Hz, and the sound is much easier for the human hearing than just input directly the voltage to the speaker. And here is the hallmark of the integrated palpation system. We use the manipulator to control the movement, and we use the laser diode with PAC to tracking the movement of experiment. All the experiment is recording by the video, and the image and the audio will recorded by the camera and the microphone. This is the interface for this system that we are designed. You can track in the movement here and see the video, and also to see the frequency for the songs on time. Then I will show a video example for our music training enhanced micropalpation. And here is the example of the And here is the example of the active music turning enhanced micropalpation, and we can easily to see and also hearing the difference of the pressure, relaxed, and scratch. This is the sound information. It can help the user understand the mechanical property online. And this is another application that we use the passive micropalpation experiment. The experiment when we can easily find when we add in the 100% ethanol to the biosamples, the force and the voltage will increase. And in a conclusion, that we develop a music turning enhanced micropalpation system, which including a high performance, low cost, durable 3D microforce sensor with a method can processing the force to the music online. This can help us to understand the mechanical properties of the biosamples. Thank you.